Hello everyone, welcome to my YouTube channel. So today I am going to discuss about modal analysis. Okay, so we will see what is modal analysis, and we will see how we see the report of modal analysis. Okay, and what is the importance of modal analysis. So see, whenever we generally start for analysis of any type of structures, okay, so we generally perform modal analysis. So in a simple way we can say that modal analysis, we generally check the behavior of the structure under seismic loading. The meaning of it is that when we start for analysis of any types of structures, then we subject the seismic load on that structures. So in with the help of modal analysis, okay, we generally see what is the behavior of the structure. Suppose that this is your structure, okay, and when we apply the seismic load here, so with the help of this modal analysis result, we see how the structure behave under seismic loading. So when we start for analysis of structures, we have to create three model. First one is that first one is uncracked model. Okay, first one is uncracked model. Second one is service cracked service cracked model. Okay, and third one is that strength cracked model. Strength cracked model. Okay, so modal analysis generally come in uncracked model. Okay, modal analysis come in uncracked model. So in uncracked model we generally check modal analysis, we perform creep analysis. Okay, so today we will see modal analysis. So modal analysis generally come in uncracked model. Okay, so how we see the result of modal analysis and how we'll come to know that our structure is safe, means we generally see the behavior of the structures. See, so after performing this modal analysis, we got this result. Okay, this is the result we received. This is the modal analysis result. How we do modal analysis already we done in previous my video. If you wish, you can go and visit. Here I will understand that how we will see the modal analysis result. See, so what happen is that in, see, here are generally 12 mode. So generally we perform 12 model. Okay, if we need we can go more, but standard is 12 model we generally perform in modal analysis. Okay, but only model 1, model 2 and model 3 is very significant, and model last model, that is model 12, is very significant for us, where we generally check the value of our structure's behavior. Okay, and what is ux? Ux is the displacement. U generally shows the displacement and x is directions. So the meaning of ux is displacement in x directions, uy is displacement in y directions, and uz is displacement in z directions. So why it's coming 0? Because our structure not will jump like this in z directions. It will either go in x direction displacement, or it can go in y directions displacement. Okay, what is sum of ux? The meaning of sum of ux is that it generally sum of all ux displacement in x directions. It's given like this. Okay, see, like this one ux, this one ux, this one value is when we combine this one, this value is when we combine these three, like that. Okay, So like that, sum of uy is displacement in y directions, means summation of displacement in y directions. See, this value 0.0729, this value is 0.0729. This value from where it come? When we add this one, like that we will get. Okay, and here we generally see rz value. What is rz? Rz is the rotations, means torsion. Okay, so we see the rz value also, and we see the ux value, uy value, and sum of ux value and sum of uy value. Okay, so how we will see? Just see. Firstly, in mode 1 we generally check the rotation, means rotation of the structure. So always remember that one thing in rotation. So rotation of the structure, rotation of the structure, what? So it should be less than 5%. First criteria in model 1. Okay, so we got the modal analysis result. First we see that rotations means rz value, means rz value should be less than 5%. If is it okay, then our structure is safe against rotations. So first we see rz value. See, this is rz value, and in model 1, what is the value of rz is 0.0021, means it is pass, means it is less than 5%. Okay, so first we generally check this one. In second, what we see? So in second we generally check either ux or uy value. It should be predominant, means either ux value or uy value should be greater than 50%. Okay, so if you see the value of ux in model 1, what is this? This is 62%, 0.62, means 62%, and it's getting 7%. So what is predominant? This value we are getting predominant. Okay, so in model 1, in model 1 ux value is predominant. Okay, means more than 50%, means 62% we received, means it is pass in model 1. Okay, now we come to the model 2. So in model 2, what we see? That in model 2 we have to check that if in model 1 ux value is predominant, so in model 2 either uy value or rz value should be predominant. Okay, so see, uy value is how much? 58%, and rz value is 5%. So which one is predominant? uy. Either it can be either uy or rz, it should be predominant, means more than 50% and all, but it should be predominant like that. Okay, so in uy the value is 58%. So in model, when we come to the model 2, uy value is 58%, means also it is okay. Now in model 3, if in model 1 ux value is predominant, model 2 uy value is predominant, so in model 3 anyhow rz value should be predominant. So what is the value of ux in model 3? That is 1%, here 4%, and rz value is 68%. So in model 3, in model 3 rz value is 68%. Okay, so means it is safe. In model 1 ux value predominant, model 2 uy value predominant, and model 3 rz value is predominant. Okay, So I hope you got it until this. Now what we see is that in model 3 also we have to check. In model 3 we have to check sum of ux and sum of ui value should be greater than 65%. Okay, this value should be greater than 65%. So in model 3 just we see, when we come to the model 3, see this is your model 3, the value of sum of ux is 70% and sum of ui is 70%, means it is greater than 65%, so it is also safe. Okay, now what we see is that we generally check model 12. In last mode the value of, means model 12, in model 12 the value of sum of ux and sum of ui should be greater than 90%. Okay, if it is okay then we say that structure is safe. So in model 12 we see that it is 92% or it is 90%. Okay, it should be equal and it should be greater than 90%, then it will be okay. So we see that in model 2 sum of ux value is 92%, sum of ui value is 90%. So our structure is safe against this also. In last thing what we check, that we check generally the time period. Okay, so how we'll check the time period, just see in model 1 and model 2 and model 3 we generally check the time period. So time period should be at least the difference between model 1 and model 2, the time period should be at least 10%. Okay, more than it is okay, but not should be less than 10%. In model 2 and model 3 also it should be more than 10%, it should not be less than 10%. Okay, so first we see the model 1 and model 2 time difference. Okay, so in model 1 time period is 0.44 second, in model 2 time period is 0.36. So how we'll see that, that is time period 1 minus time period 2 divided by time period 1 into 100. When you put this value it will be getting t1 is how much, 0.44, t2 is 0.36 divided by t1 is 0.44 and into 100. So we will be getting how much, that is 14%, means it is greater than 10%. Okay, so time model 1 and model 2 the difference between how much, 10%, means the meaning of this is that after model 1 displacement is 62%, then suddenly it will not come to the displacement again after 10% difference. Okay, again the displacement will come. It is the meaning of this only. Okay, so in model 1 and model 2 the time difference is greater than 10%, so it is okay. Now model 2 and model 3 we check. So t2 minus t3 divided by t2 into 100, just put the value of this. t2 is 0.36, t3 is 0.26 divided by t2 is 0.36 and into 100. So just you multiply, it will be getting approx 27%. So it is also getting more than 10%. So our structure is safe. So this is the criteria to check the modal analysis result. Already I said you that what is modal analysis. It generally shows the behavior of the structure under seismic loading, means earthquake loading. when we apply the earthquake load on the structures, then how our structure will behave. So only, okay. So these are the criteria for that, okay. And other thing, very important thing, I just wanted to tell you that, see, what is the meaning of this? What is the meaning of this? It should be greater than in modal 3. See, modal 3, what is the meaning of this? It should be greater than 65%. See, what is the meaning of this? Suppose that this is your structure, okay. This is your building, and when we apply the earthquake load, see, our structure, okay, suppose that this displacement is lambda. When we apply the earthquake load, this is first, and second one is that, this is also a structure, and second structure like this, okay. Second structure like this, okay. So this is your structure. When we apply the seismic load, your structure will be like this or like this, which is okay. Just tell. When you apply the structure, this is your structure, means RCC building, and when we apply the seismic load, then your structure behave like this and this. So which is okay, which is right? See, this is right, okay. Why? The thing is that already code says that when we apply the seismic load on the structure, your structure should at least participate 65%, okay. Means it generally participates 65% of the earthquake load. When you apply the earthquake load on the structure, your structure behave like this, okay. It will displaced like this, means this is your displacement. This is your earthquake load, means when we apply the earthquake load on the structure, some of the energy will be absorbed by this member and some energy will be transferred in the form of displacement, okay. And in this case, what happens is that when we apply the seismic load on this structure, all energy will be absorbed by the member itself. So this will be brittle. This structure is brittle, and this structure is ductile, okay. So the structure which is brittle, it attracts more earthquake load, and the structure which is ductile, it attracts less earthquake load. So the meaning of this is that it should be greater than 65%. The meaning is that when seismic load is generally applied on any type of structure, our structure should participate at least 65% in the earthquake load, okay. So see, when earthquake load comes, our structure will deflect like this, means it generally participating, but in this case it's not participating. So the value of this, we generally check in model 3, this value should be greater than 65%, means our structure, in this case what happen is that in this structure, our structure is generally participating 70% of participation in the earthquake load. Means when earthquake load is generally applied on the structure, our structure 70% is participating, means it going for the displacement, okay. So it is okay. So the meaning of this is that this one, we generally check this one, model 3, participation ratio should be greater than 65%. The meaning of this only, okay. I hope you understood what I told you that. And if you like my channel, and so I request you to kindly share and subscribe my channel, okay. And in next lecture we'll come to the next topic, okay. Thank you so much.